agent is the sugar. Let's see which one is reducing. And what I'll do is I'll keep this the hot water bath. Okay. So here is my hot water. I'll pour it. I'll show it to you. This is hot water. Well, see, I've put both of them, correct? One had sucrose, table sugar, one had glucose. And it's in the hot, yeah, it's quite warm. Why hot? You know what? It will aggravate the reaction. It will make the reaction faster, or else I have to wait for a long time. Now, a result should come up something like this. You see? If there is enough amount of sugar, non-reducing, traceable, low, moderate, if we have high amount of sugar, then we'll get a brick red color. If you have moderate amount of sugar, we'll get somewhat like orange color. Fine. So right now what we have is what? Blue color. Fine. Blue color, if I get blue color, that means it's a non-reducing sugar. If it's reducing, and based on the amounts, we can trace how much is present. Fine. Quick question. Try this out. Reducing sugar must have. Well, we'll try to answer this question. In the meantime, I'll just remove my gloves. And at the end, we'll see the result. Great. Reducing sugar must have free aldehyde group, free ketone group, either free aldehyde or ketone group, both free aldehyde and ketone groups. What would be the answer? It's easy. Either free aldehyde or ketone group. Fine. This is the correct answer. You know what? If you talk about the molecules which have the ketone group, right? What happens, after you put that in the solution, it will isomerize, isomerization happen, and then it forms aldehyde again. Right? For example, if you put the molecules which have ketone, they will isomerize, and there's some rearrangement. Simple words. Don't worry about isomerization, tautomerism. Don't worry about these words. Simple rearrangement will happen in such a way that it forms aldehyde, and yes, it becomes a reducing sugar. Got it? Fine. So now let us talk about the disaccharides. Okay, we have talked about the monosaccharides. Now disaccharides, di means two, correct? Yes, two saccharides, that is sugar units, two monosaccharide units joined by a glycosidic bond. Yes, something new. Let's concentrate. Take a look over here. There are two monosaccharides. Can you see two monosaccharides and see the red colored portion? I have labeled an OH group and H of another OH, correct? So that means what? It forms water, H2O. So release of water, and that results into the glycosidic bond. So both of the molecules, monosaccharides, are connected via the oxygen atom. Water molecule is released. So do you remember condensation reaction? I showed you. Yes, release of water molecule. Fine. So that's a disaccharide, glycosidic bond. Understand? Okay. Examples of disaccharide: sucrose, maltose, lactose. Sucrose. Let's see. Sucrose. We used it in our experiment, right? We'll see the result. We'll check the result. Also called the table sugar or the cane sugar. Table sugar, the sugar that we have. I guess this one that I showed you. This is simple. What? It's a sucrose. Fine. Glucose plus fructose forms the sucrose. Glucose, and you see fructose over here, forms sucrose. Same type of bonding. It's a glycosidic bond. See the position. This carbon and this carbon. Fine. Okay. Here, same type. If you just understand what is glycosidic bond, then you can easily join them and form the polymers. Let's see. Non-reducing sugar. So let's wait for our experiment. It's happening. I'll just show you the answer, the result of the experiment towards the end. Just wait for few more minutes. So I'm telling right now, we'll check it. It's a non-reducing sugar. So that means it should have the blue color of the copper sulfate. Correct? You see here. Fine. This is the position where it is bonded. Now see, it's non-reducing. Why, you know? You know why? Because remember there I told you oxygen here and forms OH. After breaking, it will form what? CHO group. This cannot form over here because the whole bonding over here takes place, is involved. So here this breakage would not happen even in aqueous solution. So these are non-reducing sugar. So here there is no free aldehyde or ketone group. Got it? Once more. So why won't it break? It seems that it will break, but it is not breaking because this whole group here, when you talk about resonance and all, so you will understand in more detail, molecular detail in your chemistry classes, but just understand right now that this bond formation, when it is joined, this here, the whole molecule here, this portion is involved. So the breakage of this bond would not happen, and hence it would not result into the formation of what? The free aldehyde or ketone group. So it's a non-reducing sugar. Got it? The maltose, it's malt sugar. Glucose plus glucose gives maltose. That means 2 units of glucose. It's obtained from barley, right? Reducing sugars. These are also reducing sugars. Fine. Great. Maltose syrup. Very common, right? Maltose. Remember, glucose plus glucose. Sucrose is, try to recall. Sucrose was glucose plus fructose. Fine. So this is maltose. Now lactose, you'll find it in milk sugar. Yes, milk. So glucose plus galactose gives lactose. Remember the structure of the galactose? How is it different from the glucose? Just one portion, right? So it's also reducing sugar. Fine. It's time to figure out our result that we have done. Fine. Are you ready for this? Okay. Let's see. Yes, we have got the results. Fine. I'll take them one by one. Wait. Let me use this one so that you can visualize properly. So, this one had sucrose. It's blue. Match it, match it. Non-reducing sugar. Now, see this one. Yes, this one had, yes, it had glucose. See, it's nearly orange. That means it had moderate amount of glucose. If I had put more amount of glucose, then I would have got brick red color. Fine, you get it? So see it properly. See the difference? So this is a reducing sugar. Glucose is a reducing sugar, whereas sucrose is a non-reducing sugar. I showed you why it is non-reducing. Are you convinced now? Yes? So if you just have, fine, just take it, take a look. Now I'll just skip it. So we got our experiment. Our experiment is absolutely successful. We got our desired result. Okay, so you can try this at home. Try to use different sugars, but be careful. Do not hurt yourself. Do not stain yourself. Okay, and I hope you understand the logic here. The copper, yes, the copper got reduced. Why? Because the sugar is a reducing sugar. Got it? Okay. So, well, that was the result for our experiment, and I'm sure you have enjoyed today's session. So that's it from me in this session for today. Biomolecules. We have introduced ourselves to biomolecules. We are coming up with more and more interesting concepts for biomolecules. Fine. What you have to do here is simple. Get cleared on the structures: glucose, sucrose, fructose, galactose. Basic: glucose, fructose, ribose, galactose. Fine. These 4 structures, if you're clear, then next level you try the disaccharides. Okay, we have talked about the disaccharides also. Try to form the disaccharides. Think about logically how the condensation reaction and hydrolysis, how they affect. Fine. And if you get hold of this reagent, which is, I'll just name it again, it's a Benedict's reagent, then you can test it and enjoy it yourself. Fine. So I'm signing off for today. I hope you have enjoyed this session. Keep revising. Keep answering the questions that I'm asking you. Fine. Okay. So stay happy, stay safe. I'll see you soon with a brand new session.